Everybody, this is Chris Luna coming at you from the coming at you from the physics room at Arizona State because I'm a physics major and a math major. Holla! I'm just gonna do a run through for my review of my mathematical structures class. It's a class about proofs, and I thought I'd take you guys along for the ride. And as everybody's real happy about that. Cool. So we're just going to run through some basic proofs, or not even proofs, really, just definitions of things. Maybe I'll do a proof later. We'll see how ambitious I'm feeling. This is my first time using this technology. It's so strange and unusual for me. But we'll see how it goes. So yeah, I'm going to just do some basic definitions here. Excuse me, this is my first time using this sort of technology. So this is A union B. And if X is an element of A union B, then that simply means that X is an element of A or X is an element of B. Cool. Let's do another one. Is A intersect B. My co-producer here is telling me that I should tell you guys that A and B are sets. So I don't even know what a set is really. It's just a group of objects. They can be sets, or they can be just regular numbers or something like that. They can be ducks or dogs or words or birds, whatever you want your flavor to be. But yeah, so A and B are just sets here. And so this is a set of ducks, and this is a set of whatever else. But anyways, so this translates into so this is A intersect B means X is an element of A, and X is an element of B. Easy stuff, not very complicated. Keep going. Next we have A difference B. And that translates into X is an element of A, and X is not an element of B. Now, I do give these recordings. I'm assuming that I'm talking to somebody who is on a similar level of understanding with these things. So if there's a topic you don't understand, then that's too bad. I'll learn to be better about that, though. Next we have this one is A subset B. Yeah, as I said in the beginning, this is kind of just a diary for me. Oops, this is wrong. So I'm not really kind of doing it so people can understand. Kind of just doing it to document my journey through college. Whatevs. So if X is an element of... Wow, I did it wrong again. So if X is an element... Wait. This translates... This translates into, for all X element A, oops, A implies that X is an element of B. Cool stuff. Happy face. Alright, moving down the list here. Just gonna erase this. Right? Let me bump up the diameter here. Alright, this we have not a subset of B. And this is just the negation of the statement. And the negation of this, we pull through negation symbol, and we do the opposite, the opposite of the opposite. That means that there is an X in A, and X is not an element of B. There exists an X such that X is in A and X is not in B. That means X is not a subset of B. Okay, next thing we're looking at is A union B is equal to the null set. Means that the intersection of A and B is empty. And in symbolic language, this means that there exists some AX such that, does not exist an X such that X is an element of A and X is an element of B. Poor little A and B. Okay, moving on. We have A intersect B is not the null set. Implies that this implies, well, let's just start again. A intersect B is not a null set, means that there does exist some X such that X is an element of A and X is an element of B. Cool stuff. Alright, the next thing is the union of a family of sets. So if X is an element of the union of a family, then that means that for all of the sets in the family of sets, X is an element of that set. That just, yeah. Okay. And then there is the, oh wait, this is wrong. What's up? This is actually a union, so this means that there exists some A in the family of sets F such that X is an element of A. Now the definition that I wrote previously is actually the one for this guy, which is the intersect of the family of sets. So if X is an element of the intersect of the family of sets, and that means that for all sets inside the family of sets, X is an element of that of those sets. Yay! Moving along. Can you believe my review is this long? It's not even long. Next thing is indexed families of sets. And those look like this. AI. And if you say X is an element of these guys, then that just means that there exists some I in the indexing set such that X is an element of the indexed A. Now we do the same thing with the intersect of an index family of sets. I think I'm saying that correctly. Looks like this. And this corresponds to sort of the same thing, except for it means that for all the indexing indices, X is an element of AI. So whereas we had existence before, now we have all of them. Yep. Oh, need to erase. No blur. I don't want any blur. Hard edge that shit. Okay. I'm actually gonna pause the video and we'll come back. Cool.